Okay, so in this section we're going to be adding and subtracting radicals. So we have a key vocabulary term we have to know. And I'm giving you the general definition, but this is really the definition that we have to worry about. So like radicals are radicals with two things: the same index and the same expression under the radical, also known as what's called the radicand. When all of the radicals are square roots, that means they have index 2. Like radicals are radicals with the same expression under the radical. For example, 3 times the square root of 2 and 7 times the square root of 2 are like radicals because the same number, 2, is under the radical. 3 on the square root of 2 and 7 on the square root of 5 are not. Why? Because 2 and 5 are not the same numbers. 3 on the square root of 2 and 3 on the square root of 7 are not, because 2 and 7 are not are not the same radical. So here we go. We want to add or subtract radicals. For you guys, that's just square roots. To do so, we need the radicals to be like. In other words, we can't do anything unless they have the exact same expression under the radical sign. Then we just add as normal. What do I mean by normal? If I have 7 of something plus 8 of something else, then I have 15, which is 7 plus 8 of that something. In this case, that something might be a square root of 2, or it might be a square root of 3, or it might be a square root of 8. Doesn't matter. It's something, and if I have 7 of something, and then I add 8 of that something, then I now have 15 of that something. And that's all there is to it. So let's look at some examples. We want to add the square root, 20 times the square root of 5 plus 3 on the square root of 5. So notice, look at our radical symbols. They have the exact same number underneath. So I just add 20 of something plus 3 of the same something, 23 of that something. And what is that something? It's the square root of 5. I have 11 times the square root of 7 minus 3 times the square root of 7. Where these are like radicals because the number and the expression under the radical sign is the same. They're both 7. So if I have 11 of something and then I take away 3 of that same thing, then I have 11 minus 3 of that something, which is 8. And that something in this case happens to be the square root of 7. Now we have minus 7 times the square root of 11 minus 5 times the square root of minus 11. These are like radicals. So I have minus 7 minus 5 of them. And what are them? Square root of 11. And minus 7 minus 5 is minus 12 of those things, which happen to be the square root of 11. Hold on just a second. This is my cat, everybody, and she wants to go outside. Normally I will just ignore her, but I could tell the meow that she was going to paw and beg, and it would be annoying, so easier just to put her outside. So it's probably 1D. 11 times the square root of 3 minus 12 on the square root of 3 plus 35 plus 3 on the square root of 3. So just like we collect like terms when we're adding polynomials, let's collect like radicals. And the like radicals are the radicals with the exact same number. They're actually the only radicals on plus 35. So I'm not going to be able to do anything with 35. Well, 11 minus 12 is minus 1. And minus 1 plus 3. So that gives me 2 on the square root of 3 plus 35. So just note 2 is equal to 11 minus 12 plus 3. So it's kind of like you can just literally treat these as coefficients to variables, and that works fine because remember, a variable stands for some unknown number. In this case, we can say, okay, let x stand for square root of 3. Works exactly the same. Same principle there. This is number E. 3 on the square root of 7 plus 5 on the square root of 21 minus 8 on the square root of 21 minus 10 on the square root of 7. So let's collect like radicals. So my like radicals are the square root of 7s and the square root of 21s. And I know you might be realizing, well, 21 is 7 times 3. Is there any way I can convert that? And you can't. 21 is completely simplified because it's the product of two primes. And those primes are not raised to any power greater than 1. So now I just simply add. So this is 3 of something minus 10 of that something. So 3 minus 10 is minus 7. So I have minus 7 of that something, and that something in this case is square root of 7. Then I have plus 5 of something and minus 8 of that something. So I have 5 minus 8 of that something, which is minus 3 of that something. And in this case, that something is square root of 21. So it's minus 7 square root of 7 minus 3 square root of 21. So here we're going to be able to add like radicals if I simplify them. And this is kind of nice because this is actually something we do in intermediate algebra. So you're already getting tools. Literally, this particular class itself is really the best preparation for people who don't, or who perhaps tried to start intermediate algebra and realized they were in over their heads. This is the perfect way to get ready for it. So I don't have like radicals. So let's look at 20. 20 is equal to 4 times 5. So let's look at 20 now. That way. 9 times the square root of 20, which is the square root of 4 times 5. Well, the square root of 4 times 5 is the square root of 4 times the square root of 5, which is 2 times the square root of 5. So, plus 9 times 2 times the square root of 5. So that's 8 on the square root of 5. I'm just bringing it down. 9 times 2 is 18. Look, I have like radicals. Square root of 5, square root of 5. And 8 plus 18 is 26. So if I have 8 of something and I add 18 of something, I have 26 of that something. In this case, I have 26 the square root of 5. Because the square root of 5 is that something. Minus 7 on the square root of 2 plus 9 on the square root of 50. Well, that's not going to be so bad. That's the same thing as minus 7 times the square root of 2 plus 9 times the square root of 50, which I'm going to write as the square root of 25 times 2. So hint, when you're doing these and you're searching for a like radical, that's a 2, that's a 50. Take 50 and divide it by 2 and you should get a perfect square. So I'm not doing anything with my first term there. But I realized that the square root of 25 times 2 is the square root of 25 times the square root of 2. And the square root of 25 is 5. So it's the square root of 5 times 2. And 9 times 5 is 45. So now I have minus 7 of something and I add to it 45 of that something. So this is 45 minus 7 of the square root of 2, which is equal to 38 on the square root of 2. We've done that one, so let's do the next one. Minus 8 square root of 3 minus 3 square root of 75. So let's just use what I just told you. We're going to add these. So I need to somehow convert the square root of 25 to something times the square root of 3. So I'm going to come over here and I'm going to divide 75 by 3 and I'm going to get 25, and that's equal to 5 squared. So it's minus 3 times square root of 25 times 3. It's minus 8 times the square root of 3 minus 3 times the square root of 25 times the square root of 3. Well, the square root of 25 is 5, and the square root of 3 can't be simplified. Minus 3 times 5 is 15. So this is the same as minus 8 times minus 15, really just using the reverse property of distribution. So my answer becomes, if I have minus 8 of something and then I take away 15 more, I have minus 23 of that something times the square root of 3. And the last one, variable terms. We'll do them all. I've just got to take a note down here. Minus 10 the square root of 48, because I can't scroll down any further than where I'm at. Oh, there's 3 on the square root of 75 again. So let's do number 10. That seems non-obvious that that could be simplified, but we'll see. So the next one was minus 10. I don't know what number it was. It doesn't really matter. Minus 10 on the square root of 48 minus 3 on the square root of 75. So let's go over here and let's look at our 48. 75 we kind of know. Let's divide it by 2. That's 24. That's 2. 12. That's 2. 6. That's 2 and 3. So 48 is 2 to the 1, 2 to the 4th power times 3. And 75 is equal to 5 squared times 3. Okay, so this is equal to minus 10 times 2 to the 4th power times 3. This is minus 3 times 25 times 3. So this is minus 10 times the square root of 2 to the 4th times the square root of 3. The square root of 2 to the 4th is 2 to the 4 divided by 2. And of course the square root of 3 is the square root of 3. So this is 3 times basically I'm using the product rule right here, the square root of 25 times the square root of 3. The square root of 25 is 5 times the square root of 3. So this is equal to minus 10. 2 raised to the 4 divided by 2 is 2 squared times the square root of 3 minus 3 times 5, 15 on the square root of 3. So minus 10 times 2 squared is minus 10 times 4. So that's minus 40 on the square root of 3 minus 15 on the square root of 3. Notice how they broke down to like radicals in the end. So I can add these, or subtract them as it were. So that's minus 40 minus 15 times the square root of 3, which is the same as minus 55 on the square root of 3. Minus 5 times the square root of 8x minus 6 the square root of 18x. Okay, let's do that one. We want to simplify minus 5 the square root of 8x minus 6 on the square root of 18x. I'm going to do this in my head. So I know that 8 is 4 times 2 times x. And I know that 18 is 9 times 2x. So 4 times 2 is 8. 8 times x is 8x. 9 times 2 is 18. 18 times x is 18x. So this is the same as minus 5 times the square root of 4, which is 2, times the square root of 2x. This is minus 6 times this. I'm just using the product here, the product rule. Remember, square root of 9 times 2x is the square root of 9 times the square root of 2x, which is 3 times the square root of 2x. So the square root of 9 is 3. Square root of 2x cannot be simplified. So minus 5 times 2 is minus 10. Square root of 2x. Minus 6 times 3 is 8 minus 18. Square root of 2x. These are like radicals. So that's the same as minus 10 minus 18. The square root of 2x. Minus 10 minus 18 is minus 28 on the square root of 2x. And the last one, minus 5, oh, it won't be so bad, x squared plus 3x plus 8 on the square root of x squared. You should be able to do that one in your head. We won't do it in our head. We will write it down, but it's not hard. So we have minus 5 times the square root of x squared. Remember, we're assuming our variables are all positive, plus 3x plus 8 on the square root of x squared. Well, the square root of x squared is, just looking at this part right here, is x. And the square root of x squared is x. So now I'm just adding minus 5x plus 3 plus 8x, which is the same as minus 5 plus 3 is minus 2 plus 8. That is 6x. And we're done.